Okay, so we're going to look at P-3 today, and then we will slow it down a little bit when we get to P-4. So P-3 is linear equations. And inequalities. That'll be your favorite part. If you happen to look at your textbook, they have a lot of information on the various properties that we use to solve equations with. I'm not going to make you memorize properties and have to regurgitate them in a proof. You're welcome, so you can ignore that part of it. One of the few things you'll thank me for. All right, example 1. All of these we're going to essentially solve. So if you just want to put general directions on me to solve, that'll work. Prove that x equals 2, or x equals negative 2, is a solution of, thank you, we just started our notes, so you're correct. X cubed minus x plus 6 equals 0. So what are you going to do to prove that? Yeah, just plug it in, right? So we're going to use substitution parentheses. And remember that it says prove. Remember yesterday when we had to prove with Pythagorean's theorem? Are you having trouble seeing it when you move up from it? Are you positive? Okay. Do you normally wear glasses? You just don't like to wear them. You would look handsome in glasses.
I definitely would not.
I could show you pictures of me with glasses and then you'll change your mind. And I'll show you that as soon as I'm done with the lecture. So you'll change your mind. Alright, so we're just going to plug negative 2 in for every x value. Use substitution parentheses. Pay attention to signs, especially here, because it's a minus minus. So negative 2 cubed is a negative 8. Plus 2, take care of your double negatives. And so this is negative 8. These two add to give me positive 8. And so doesn't 0 equal 0? When you're proving it, you have to show the left side equaling the right side. You can't leave that part on. So don't stop short here. You just prove it. Done. All right. Let's look at actually solving an equation. So example 2. Two parentheses, 2x minus 3, end parentheses, plus 3 parentheses, x plus 1, end parentheses, equals 5x plus 2. Are you comfortable solving that on your own? Yes. So I'm going to just quietly solve it up here. You quietly solve it there. I'll try to not talk. It's difficult for me, but I'll attempt it. And then if you have questions along the way, wave your hand madly at me. Remember, I'm blind. And I will answer them. Now your book loves decimals. Remember our conversation yesterday? Is there a decimal original problem? Yes or no? Don't give me a decimal answer. Math Excel will accept a decimal answer. I won't on your test. I'll mark you a smidge off for it. It's just my teacher preference. Plus it's general practice. Any issues with that? I should probably more work than some of you, which is fine. We just can't go from here to the answer with nothing in between. Now, how could you determine that that was the correct answer?
Plug that.
Yeah, you could plug this back into the original problem. It'd be a pain because it's a fraction, but you can do it. You can use your calculator as well. All right, so there's that one. Let's look at a little bit more difficult one. And I think I can fit it in this little space here. We'll find out. So we're going to solve 5y minus 2, all divided by 8, is equal to 2 plus y divided by 4. What is it that you don't like about this? The fractions. Do you remember how you can get rid of your fractions? You cannot cross multiply here only because I could if I had that. Yeah. Why are you multiplying everything by 8? Isn't your least common denominator here 8? And make sure that you multiply every term by 8, not just the fractional term. So I want to multiply this term by 8 over 1. I want to multiply the 2 by 8, and that's the one that a lot of you tend to forget. And I want to multiply the y over 4 by 8. And so that gets rid of your fractions. So we end up with 5y minus 2 equals 8 times 2 is 16. That's okay. Bless your heart. If you want to just gently click them wherever is available. I have the bookshelf right there, but if you just want to stack them up there because it's easy to do, that's fine too. Thank you so much. And then the 4 goes in the 8 here twice, so I end up with the 2y. Now you're comfortable solving that? Much easier to solve. So continue solving. Are there any restrictions in this particular original equation that I would have to worry about? Restrictions in fractions come where? What do you have to worry about? How about a denominator equaling 0? Is it possible for any of the denominators to be 0? Nope, there's no variables in the denominator. I can check my answer by plugging it back in. I'm not going to here, thank you. All right, so we're good with that, correct? Oh, you're still writing? Sorry. You okay to get to the solution? Is everything good? All right, so let's look at example 4. Look at an inequality. They tend to have some issues. 3 parentheses, x minus 1, plus 2, less than or equal to 5x plus 6. So when you solve inequalities, it's exactly the same as solving an equality statement with the exception of one thing. Do you remember what that is? If you multiply or divide across the inequality by a negative. Not if when you multiply or divide you get a negative, but if you're actually multiplying or dividing by a negative. Then you have to flip your sign. So that's one thing you have to watch out for. So I'm still going to distribute the 3. So I get 3x minus 3 plus the 2 less than or equal to 5x plus 6. Collect your like terms. I get 3x minus 1 less than or equal to 5x plus 6. I'm choosing to subtract 3x to avoid that whole negative issue. If I can avoid multiplying or dividing by a negative, I will, and I don't have to worry about flipping the sign. So I end up with negative 1 less than or equal, less than or equal to 2x plus 6. Subtract 6. I'll get negative 7 less than or equal to 2x. And I divide by 2. I'm personally dividing by a positive. I don't have to flip the sign. If you chose, because you like your variables always on the left side, that's fine. I will tell you that Math Excel won't accept that answer because they probably will put an X already in there for you. So if I were to flip the X and the negative 7 halves so that they're on the preferred side, what happens? Yeah, you have to flip that sign as well. So instead of a less than or equal to, I end up with a greater than or equal to sign.
Why did you get 7?
Because up here when I subtracted 6, that's the negative 6. Add and keep the sign.
See, I like did it differently. I subtracted 2 from 6, got 4. Then
Oh, you subtracted 2 up here.
yeah. And
So
then
if you
got
subtracted
4.
2, you get 4,
And
and then if you
plus
subtract the 4, you'll still get a negative 7. Right? So if, let's do it your way. If,
Oh, I just did it wrong. I didn't agree there and throw 1 there.
does that make sense?
Yeah.
Okay. Anybody else have issues with that? Now let's graph it. Oh, darn. This one's not so bad to graph. Let's graph it using interval notation graphing, right? That we worked on earlier. So your boundary point is negative 7 halves, which is what mixed number? Negative 3.5. So you put 0 here, negative 2, negative 4. So since I partition my number line to where I don't have negative 7 halves as a number on there, I'm going to actually physically put it in there. So here's negative 3.5 would go right here. So this is negative 7 halves. Then, do I have brackets or parentheses? Because of it equals to brackets or brackets. And if I were to, well, let's go ahead and write this in interval notation first before we graph it. So this says x is greater than or equal to negative 7 halves. What is my leftmost endpoint? Is it infinity or is it the negative 7 halves? Yep, so it's a negative 7 halves, comma, and it's going to go greater than forever. So positive infinity is on the right. What always goes with infinity? Parentheses or brackets? Parentheses. And then here we said it was a bracket because of equals. So this is our interval notation. That's going to help us with our graphing. So we're going to graph a bracket that opens to the right and an arrow that goes to the right. And we could actually check to see if our solution is correct by looking at the graph. What's a good checkpoint on this graph? Easy checkpoint? 0. 0 should make my answer up here turn out to be true or false. True, because the line is over it. So if I plug in 0 here, I have 0 minus 1 is negative 1, times 3 is negative 3, plus 2 is negative 1. So at 0, I would have a negative 1, less than or equal to, put 0 in here, we get 0, plus 6. So is negative 1 less than or equal to 6 true or false? That is true. So it seems like I put my line in the correct direction. Now we could also choose something over here and check it to make sure that comes out to be false. You always want to do some checks. Questions on me? Okay. Number 5. I have 2 more. Yes. No, I flipped the sign because I switched my x and my -7 halves. I switched them. So kind of like Vanna White on Wheel of Fortune, when you switch something and flip it, you have to flip the sign. Now, if I were flipping x equals 2, and I flip the 2 and the x, when I flip an equal sign, it still looks the same. You just didn't realize you were actually flipping equal sign too. So yeah, the only other time that you flip an inequality is if you reverse the left and right side. All right, so example 5. This time we have x divided by 3 plus 1/2 greater than x divided by 4 plus 1/3. Based on what we've done before, what are we going to do first? Look at the 3, the 2, and the 4. What's your least common denominator? 12. So I'm going to multiply every term by 12 because I don't like fractions, and I'm pretty sure the majority of you don't like them either. You're going to multiply every single term by 12. So the 3 cancels into 12 4 times, so I have 4x, plus the 2 cancels into 12 6 times, greater than. 4 cancels into 12 3 times, so I get 3x. 3 cancels into 12 4 times. That's much easier to solve. So now continue solving. And then graph your solution. Write that in interval notation and graph it. Anybody have issues with my solution? Good with that? Alright, so if we put it in interval notation, we only have one boundary point, so that implies we also have a infinity or a negative infinity along with that. So if I'm going greater than -2, yes, ma'am.
So is it the same thing if instead of you have x greater than -2, is it saying -2 is less than -x?
No, because you have to solve for positive x.
So if I got that by doing that, then I can just flip whatever? Because
You're going to have to multiply by a -1,
well,
which flips it, and then flip the left and right side, which flips it again. Because if you actually came up with a solution of, what did you tell me?
I got 2
2 less than -x, right?
Yes.
Which is not incorrect, but you haven't solved for positive x. So I'd have to multiply both sides by -1, which makes this -2. It flips this to greater than and makes that positive x.
Okay.
To graph, you always want to look at your x on the left, so then you're going to have to flip the left and right side, which means you also flip that inequality. Somewhere you must have had the wrong sign on there because it's not the same as mine. So
Well,
let's,
that's not the same as yours.
huh?
The x on yours says it's greater than.
Right, that's what I'm saying. Something's wrong on yours. You probably shouldn't have had a lesson there. So let's see how you got that. So tell me what you did to solve. Did you get to this far?
Yeah.
Okay, what did you do there?
Then after that, I subtracted 4 from 4 and 6.
Okay, so you subtracted 4 and 4. So that gave you a 4x
Plus 2.
plus 2 greater than 3x. What'd you do now? Now you subtracted the 4x? Okay. In the future, if I were you, I would collect your variables first rather than your constants, because this is how you ended up with a negative situation, because you were like, okay, I don't want to move the 3x over. Am I right?
Yeah.
So I always move variables before I move constants. So make that a habit. And then, so you ended up subtracting the 4x. That makes us a 2 here. This doesn't change because I didn't multiply or
I just
divide.
It's like, oh, okay.
Yeah, no, because I didn't multiply or divide, so it doesn't change.
Okay.
So now from here, you need to solve for a positive x.
Okay.
So now you're going to multiply everything by a negative 1. That makes this negative 2. That flips this, makes this a positive. Now you have to flip the left and right side, which also flips this to a greater than, and now you and I agree.
Okay.
Okay? So it can be done differently. But you moving that 4 first created all of these negative situations and all of the flippings that had to go on. I avoid that like the plague.
So start with the 1.
Yeah, and the way I avoid it is you always look at your variables first, and I move the smaller variable. It doesn't matter which is on which side. I move whichever is smaller. So because the 3x is smaller than the 4x, I moved that one. If they had been on reverse sides, I would have still moved the 3x. Okay? And in that way, I avoid having to flip a sign until the very end if I had the x and the negative 2 on the wrong sides.
Okay.
Because for inequalities, you definitely want your x on the left, especially for graphing purposes. So since I have one boundary point, I know I have infinity in that. Because I want to go to the right of negative 2, I know that my infinity is going to be to the right of negative 2, and that implies it must be positive infinity. Because there's no equals to, there's parentheses around negative 2. So then when we go to graph that, my boundary point is at negative 2. I will have a parentheses at negative 2, opening to the right, and an arrow going to the right. So again, that, yes. Say that again. When I looked at the greater than, so I have my x, I want to go greater than negative 2, so here's my negative 2. If I want to go greater than, that has to be to the right, because numbers are greater to the right. So that means that my infinity goes on the right side, which if it's on the right, it's positive. If this had been less than, it would tell me I'd want to go to the left of negative 2 forever. So my infinity would be on the left side of negative 2, and if it's on the left side of the 2 boundary points, it's having a negative.
So every time it's going to be a 1.
Correct. Yep. All right, so we're good with that. Let's check it real quick. So again, the easy checkpoint is 0. My other favorite one is 1 or 10. These are all easy to plug in. So if I put in 0 here, doesn't that give me 0? Plus a half would give me 1/2. Greater than, put in a 0 here, that's 0 plus a third. Is half of a pi bigger than a third of a pi? Yes, so that's true. And I want it to be true because the line is going in this direction, so that works for me. All right, last problem. Example 6. So you're going to do a double inequality, so a sandwich inequality. Negative 3 less than 2x plus 5, all of that divided by 3, less than or equal to 5. Sandwich inequality implies we have an and statement, which implies that you have a beginning and an ending point and a line in between. Not always, but usually. You also have 3 parts to this. You could split this into 2 different inequalities, but we're in pre-calc. I want you to start to think that what I do to one side, I do all 3. And work from the middle out. First thing I want to do is get rid of the fraction, right? So I want to get rid of that denominator, which is 3. So I'm going to multiply everything here, all 3 sides, by 3. So I end up with a negative 9 less than the 3's cancel. So I have a 2x plus 5 less than or equal to 15. So that looks prettier, correct? Then you're still focusing on the inside and working out. I'm going to get that 2x by itself. How do I get rid of a positive 5? Subtract it. So if I subtract the 5 in the middle, I have to subtract the 5 on the left, and I have to subtract the 5 on the right. Whatever I do to the middle, I do to all 3 sides. So I end up with, add and keep the sign, negative 14, less than, those cancel, so 2x, less than or equal to 10. Don't lose those inequality signs. Then still focusing on the middle, how do I solve for x? So if I divide the middle by 2, I have to divide the right side and the left side by 2. I am not dividing by negative, so I don't flip signs. I end up with negative 7 less than x less than or equal to 5. So let's write our interval notation. These are already in order from smallest to largest numbers, correct? Using my boundary points. So I have a negative 7, comma 5. Do I include the negative 7 with a less than sign? Nope. What about the 5? Yes, so I should have a bracket there. So when I graph this, and then we're going to do 3 checkpoints because the 2 boundary points are going to partition our graph into 3 pieces. So here's my negative 7, and here's my positive 5. So I have parentheses on the negative 7, and bracket on the positive 5. And should have a line in between. Let's check it. 0 is a great checkpoint. So if I put 0 up here, I get 0 plus 5 is 5 over 3. So I get 5/3 is less than or equal to 5 and is greater than negative 3. So 5/3 is what? 1 2/3? Definitely less than 5 and definitely greater than a negative number. So this is true. So it seems reasonable I have a line here. Choose any number to your right. I'm going to choose 10. It's easy to work with. So if I choose 10 on the right, I should come out through false. I've got 10 times 2 is 20, plus 5 is 25. So that would give me 25/3 less than or equal to 5, greater than negative 3. Well, it's definitely greater than a negative. So that's true, but both have to be true for there to be a line there. 25/3 is what mixed number? 8 and 1/3. So that's not less than 5. That's false. So it makes sense that there's no line there. And then out here I'm going to choose negative 10. So this would be negative 20 plus 5 makes it a negative 15/3 less than 5. Well, that's true because a negative is less than a positive. But is that greater than negative 3? So this is what mixed number? Or, I'm sorry, that goes in there evenly, doesn't it? What number is that? Negative 5. Is negative 5 bigger because we're reading it backwards than negative 3? Nope, it's actually smaller. You're more in debt, right? With negative $5 than with $2. You have less money. That's false. So our graph appears to be true. Questions on that? Okay, so tonight's assignment is P-3.